Okay, so if anyone's seeing this, we are testing out some live stuff right now. Okay. Are we live? We got to make sure this is working. This is the first time I've gone live on YouTube on this channel. I've done this before, but it seems to me... Okay, so we have some evidence from the machine. So... I gotta switch account. Switch to no QC. That's the correct channel. All right, excellent, excellent. It says we're doing Laplace equations, which is what we wanted. We should have good audio. I'm not using headphones because I don't have any audio that I need to do. But in the YouTube studio, I'm not seeing evidence of anything yet. Here. Just testing. For now. My J's and T's in cursive look the exact same. Isn't that fun? Looking for, I guess, going into the content thing. What are we doing? What are we doing? Go to your channel, and we should find something on the thing. Cool. All right. Now let me... Oh, no. Is there something going on here? I gotta mute this. Oh, okay. I look fine. I look fine.
What are we
cool. I'm going to send somebody a text. Whoa. My tablet's acting up. We'll be on in a second, folks. Doing some real stuff, even though there's no viewers. We're gonna act like there's viewers, just in case this this just gets us a thing. Whoa. Doing that. Docs. Chat. Oh gosh. Do that. Yeah. Okay. Actually, is this gonna be a little better? Oh, I can't do the cool one. Oh well. We've got chat, we've got YouTube analytical health. We got the things are rolling. All right. So now we're gonna fire text off and we're gonna get going. It's a secret. Okay, come on. You know, while we're talking, I want to do more on this channel, and I'm probably going to rename it. Something is very weird about my channel's banner and also the thumbnails, and I wonder if it has to do with the fact that I'm using... I don't know. Weird things are afoot. I'm going to have to fix them. So we're going to go... Okay, so let's get started. So today we're going to be doing some Laplace transforms using the definition of what a Laplace transform is. So a Laplace transform... Dude, they're so weird. They're so weird, but they're kind of cool. Where the heck is my pen? Oh, I found the pen. It's right here. Okay, let's roll. So, Laplace transforms are interesting little things. I'm trying to like set up to where I can see the chat and I can see my homework type stuff. Cool. For reference, the homework that I'm doing, every person gets randomized problems, so not the easiest to cheat on and all of that, although you can kind of do it and it can be told. It really is one of those things that we can, it's relatively sort of GD proof, and not a lot of people know this channel exists. So anyways, I digress. So we're going to start with the Laplace transform of e to the negative 8t plus 3 equals something. So we're going to start with what the definition of a Laplace transform is. So a Laplace transform of f of t is the integral from 0 to infinity of e to the negative st times f of t dt. Now, what you're basically doing here is transforming from the t variable, or the like time, where t would be time, to frequency 1 over t. That's one way people describe it. And what we're doing in this example here is we're taking this, you can barely see the yellow. That's not a great yellow for going against white. You can see this guy, that s, is what's going to be left over. So in the equation, and the t's are going to go away. And the reason that the t's are going to go away is because when we evaluate the definite integral at 0 and at infinity, those t's are going to go away. They're going to be a value. Well, what's t of 0? It's a 0 or it's 1 or something. What's t of infinity? It's some other number. But s has been treated like it is a constant. But now it's a function of s. And that's usually going to be called, is going to equal some f of s. And that's how you would typically write it out. So this is the first example problem. I'm going to go back to boring black. Actually, no, we're going to use gray. We're going to use gray. Why are we going to use gray? Because we can drop it down and we're going to have more space to play around with this thing. So we're going to start by plugging in our f of t, which is this guy. F of t into the form, the integral from 0 to infinity of e to the negative st times e to the negative 8t plus 3 dt equals something. So we can combine some of these together, where we know that e to the negative st times e to the 8t plus 3, well, that's e to the negative 8t plus 3 minus st, all that's the same. And we can work with that way. We can also pull out a constant. There's that 3 here. That's a plus 3, so we can pull that out. So we're going to simplify this. So let's start with saying, all right, 0 to infinity of e to the 3. We've pulled that out, and that's because with Laplace transforms, just like with integration or anything else, you can pull these things out. Or we're doing the integration. But later on, when you use the form and you start doing the, we've already solved it, and this is what you're doing, you're going to start just knowing that that's one of the features that Laplace transform has. And then we get e to the negative 8t minus st dt. And we can combine these together in a way that's nice and interesting. Equals e to the 3... e to the e cubed, 0 to infinity, e to the t, and those are both negatives. So we're going to say e to the negative t. I'm going to distribute that out. 8 plus s dt. Now, we're going to integrate this. Pretty easy integral. To do. Now, what we do is we say, well, anything that's not the t, we're going to drop it down into the denominator, and the t stays the same in this particular case. Although if you were to do this, you're taking the derivative where the integral of e to the f of x is 1 over f prime of x times e to the f of x. Blah! Fell off the page. You get what I mean. I'm not focusing on that subject right now, but we're gonna do the thing. Okay. So that's gonna equal e cubed, open brackets. That's going to be, it's t8 minus s. It's really just 8, negative 8 minus s. Yeah, that's it. And then it's e to the negative t8 plus s. I did something weird with distribution, but it's like negative 8 minus s. It's probably a little bit easier since we've multiplied t by both, and all we're doing is getting rid of that t by doing the derivatives of both of those. And we're evaluating this at 0 and at infinity. So at infinity, that negative t is infinity. That goes to 0. So this is going to be 0 minus, what is it? We're 0. The negative t is 0. Negative 0 times all this. That's e to the 0. That's 1. Minus 1 over, and we're going to negative 8 minus s. Voila. And we can go ahead and distribute out some of these things to make these a little bit more simple. Negatives and the negatives cancel, because we're going to say that it's, to be very explicit, negative 1 over negative, open parentheses, positive 8 plus s. That negative can be moved to the top and the bottom. The negative and the negative cancel, gives us a positive, equals 1 over 8 plus s. Bam. Ba boom, ba bing. You did the thing. So, and that's, well, hold on. Wait a minute. We made a minor mistake. Because mistakes happen. E to the 3, right? Because we multiplied this whole thing by e to the 3. And that goes down there. So, pretend that was there the whole time. Let's, yeah. I like using arrows too much. E to the 3. Okay. Correct. We got the first one right. I'm using a little computer. I'm not going to show exactly what it is because, you know, I don't want to dox myself necessarily, even though no one's watching this, I think. Is anyone watching this? No, I'm curious. Do I have a watcher? No, no one's watching this yet. That's fine. That's fine. I'm just kind of having a nice time doing this thing with the possibility someone either is currently watching or is going to watch this VOD. Which is more likely. Okay, so we're going to hit the plus button. Where's the plus button? Give me the new page. New page. Give me a new page, please. New page. No, cancel. No. Bam. Damn it, I gotta erase everything. I gotta erase everything. Come on. Goodness gracious sakes alive. Okay. Bada boom, bada bang. Cool. All right. Negative 8 bam. And we are finished. Okay, gonna hit this thing, and we're gonna go for a piecewise function. Piecewise functions are interesting. So we've been given a little like graph. I'm gonna copy this image and we're gonna paste it. Can we paste images in here? Oh, that's so cool. That's magic, dude. That's so cool. Okay, this is our piecewise function. Whoa. Maybe this is... Nope. That's wild. I'm kind of geeking out about this. Wow. That's crazy. Can I use the selection tool? No. There we go. Moving that to the right. Now we're going to go into this tool again. Okay. So this is a piecewise function, f of t, which is right, and this function is 0, where t0 is smaller than, I think it's equal, yeah, t, which is smaller than 1, and it is, so we're going from 1 to 2, 0 to 2, so it's 2t minus 2, because it would have gone to and it would have hit like here at negative 2, right? So there's a slope intercept of that. Oh, thank goodness it doesn't erase images. I was afraid of that for a second. 1 is less than or equal to t is less than, yeah, that's it. It doesn't. For all we know, it goes like, am I going backwards? Yeah, I'm going backwards. Woo! Yeah. All the way to infinity. Okay. So, to express this in a way that we can do the Laplace transform on it, we need to make it something that we can differentiate. And in order to make it differentiable, and what do I mean by differentiable? I say differentiable. To make it one function, right? We need something that's not piecewise. So how do we do this? We're going to say that f of t equals f1, which is, this is the general case, f1, open bracket, 0 times, oh, no, sorry, open, is 0 smaller than t smaller than 1, which is u of t minus 0, or just u of t, minus u of t minus 1. Okay, what are the u's? What do they do? Well, the u's are special functions that are kind of bizarre. So what a u function does is it is a function that is a switch. It's a binary function. So if it's from 0, anything smaller than the value of 1. So if this is u of t minus a, anything smaller than a is going to be 0. Once it's a and bigger, the function is 1. So if we multiply any function times this thing, it lets us flip the function on and off. If you subtract that same u function, you're doing the exact opposite. You flip it off. Anything a or larger is now 0, anything smaller is 1, is what it effectively does. So what we can now do is we can express a piecewise function in one line to say, okay, from 0 to 1, it's the first function. Cool. So we turn it on at 0, u of t minus 0, and then we subtract where we want to turn it off at 1, t minus 1. It's minus because mathematicians are weird. I don't exactly know why that's the case, but it is the case, so it's opposite signs. And I don't know if this is like over like every variable, like all the way from 0 to infinity, or if it's from negative infinity to infinity, so for all real numbers, or if it's just from 0 to infinity. I'm only working in from 0 to infinity, so I'm going to treat it like it's only from 0 to infinity, because I don't really care anything else. Okay, and then we're going to do plus f2 to be general, u of t minus 1, and we don't have to turn it off, because we haven't, it goes like, whoop, it just goes all the way up for forever, as far as we know. So there we go. So now, how are we going to set this up? F of t, for our problem, equals 0 times this, so guess what it is 0, plus f2. What is f2? It's, open parentheses, 2t minus 2, open bracket, u, and we don't even have to do an open bracket here, u of t minus 1, because that's when we're turning the function on. This is called the first translation theorem when it comes to taking the Laplace transform of something, or taking the Laplace of this is going to be the first translation theorem. And that, something that I've always found a little bit funky, still kind of trying to like, okay, first translation theorem, second translation theorem, seems a little bit intimidating because it's like, well, the first translation theorem. It's like a big word and we don't like big words, whatever. But, oh, look at that, camera jiggled a little weird like that. That was strange. We love rolling shutter. So, u of t minus 1. So, what this basically says, if you have, so the first translation theorem, let's go back to, we'll do a nice blue color. Blah. Okay. So the first translation theorem. Let's talk about that a little bit since I haven't mentioned it yet. Oh, am I going to have enough space? No, I'm not. So we're going to do this. The first translation theorem. Okay, for reference, I'm teaching myself cursive. I'm switching to cursive handwriting, so if my handwriting is a little bit slower, that's why, and my handwriting is significantly clearer. If you think that's bad, like it's like translation theorem. Like that's a mess, right? And that's faster, but like you can't read that. So working on it. Pardon that. So first translation theorem. What does that say? Well, if you have some function of t times u of t minus a, right? You know what that's equal to? No, that's equal to is equal to, or the Laplace of this whole thing. Obviously, this is what we're doing. We're doing Laplace transforms. It is e to the at. I think it's e to the at, or is it e to the negative? Or sorry, as. Because we're in s. F of s. Or it's e to the negative as. Let me go look that up. First translation theorem. First translation theorem. This is an important thing to do. One of the nice things, by the way, I am literally studying right now. Oh, it's the opposite. It's the opposite. Okay. It's the exact opposite. I think I'm doing the second translation theorem. Second translation theorem. Yeah, this is me studying this stuff. I'm teaching it to no one, maybe a few people, in order to learn this stuff better. So I'm learning. I'm learning in front of all of you right now. Hello. None of you right now. Okay. So hold on, let me respond to a text while I'm looking at that second translation theorem. H of t f t minus a, h of t minus a, f. Yeah, I think that's, yeah, so it's heaviside functions, also known as piecewise functions. That the guy Heaviside's a wild last name, by the way. Okay. All right, so the second translation theorem. I'm going to pull this down from unl.edu. This is both of them. This is cool. I actually kind of like the typography. It's kind of neat. So let's look at the first translation. This is really studying. Okay, let's check this out. Let's check out what this guy is all about. Look at this. That's nice. So that's first translation theorem. So it's you see how I did the e to the, okay, so if it's e to the at times f of t, right? Then it's the f of s minus a. And then the second translation, it's kind of the inverse, whatever. But if it's f of t minus a, f of t minus a times h of t minus a equals e to the negative as f of s. Okay, so that minus a is important. That's important. So t minus 3, 0, 12. Y0 is 1, Y prime 0 is 0, so that's oh yeah, this is an IVP initial value problem. I'm saying the result y of s. No, let me I'm glancing too fast. So don't we love having ADHD? Let's see. Example 1, g of t 0, c is smaller than 3, t. Okay, this is actually pretty similar to this is actually very similar to the problem we are looking at right now. So to find the Laplace transform of g, we need to identify the components on the left side of the second translation theorem. To cite this, by the way, yeah, like go to math.unl.edu/this. This is the link. I'll throw it in the chat, actually. Let me throw this in the chat. Bam. And then we'll throw this one in the chat too. Yeah, that's the second translation theorem. And just for fun, I'll throw that first one in there too, so that anybody who's watching the VOD can see that. Like I said, I don't know if I'm throwing it up there or saying up here, but there you go. So we're citing stuff. Okay. To find the Laplace transform of g, we need to identify the components on the left side of the second translation theorem, then identify the components on the right side, and then apply theorem. Right. That makes a ton of sense. So what we're doing is, now they're using a different notation than I was taught, this h of t minus 3. And so I believe that what we need to do is go from, I've dropped 818 frames. Huh. That's not great. So we'll see if we drop more. What we need to do is go and look at negative 3s f of s. F of t minus 3. So what we are doing right now, and this is, I think, a tricky part that I'm missing, is you have to do f of... So we got to correct something. So here's what we're going to correct. Boop. The boop. Yeah. Second translation theorem. F of t minus a. U of t minus a is that. That's what that is. So here's what we're going to do. This is why they did the minus 2. This is wild. This is wild. You ready for this? So we're going to go back up to this. We're going to close off this little bit here. Okay. So looking at the problem, I feel like I'm covering too much of my face up here. Bam, that's better. It's not in my face anymore, although I hope that I still don't sound bad and I'm not getting too many plosives. Any plosives in there? Because I have to look down a lot because I'm looking at my Wacom tablet. Cool. So, second translation theorem. F of t, the Laplace transform of f of t, equals okay, so 2t minus 2. So what we need to do now is transform that 2t minus 2. Every t we're going to replace with t minus 1. I believe. Let's go look that up. Where's the t plus 1? Let's just make sure. Just double check. T minus 3. Yeah. So f of t minus 3, h of t minus 3. Let's just do it. Yeah. Okay. So f of t minus, in this case, 1. So that's, that is the Laplace of, I'm putting too much pressure on this pen. 2, and then it's t minus 1 minus 2, u of t minus 1. Okay. That's going to be equal to this. E to the, just e to the at. There is no negative, right? Or say the as. E to the as, in which case this is e to the negative s, because negative 1 is a, times f of s. So, times the Laplace transform of 2t minus 4. I believe that's correct. And we can pull this 2 out. So 2e to the negative s, Laplace transform of t minus 2. And ain't that easy? It's so easy. We can break this up. Equals 2e to the negative s. Open parentheses. Laplace of t. Ooh, it's easy. Minus Laplace. Open parentheses. Of 2. What? That's so easy. We can do it in our heads. There's tables for this. It's 2e to the negative s times 1 over s minus, or s squared, because we're t, minus 2 over s. Bam! Look at that. Look at that answer right there. What should be wrong? Okay, let's see if we got it right. And if not, let's make corrections and learn. All right. 2e to the negative, no, 2e to the negative s times 1 over s squared. Oh. I can't forget. So I'm trying to remember if I'm on my French keyboard or my English keyboard. Because if I'm on my French keyboard, it does weird stuff. Which is why I'm trouble typing sometimes. Minus 2 over s. Let's see what we got. Okay, so that was incorrect. I'm going to try one more thing, and the other thing I'm going to try is I'm going to try not replacing that t minus 1. Because it's possible the way that I was taught how to do this, by breaking this all down, accounts for that. So let's do that. So 2t minus 2. 2t minus 2, ut minus 1. Let's just do that. All right, 2t minus 2. That is going to be e to the negative s times the Laplace transform of 2t minus the Laplace transform of negative 2. Now, if this isn't right, it's also possible we forgot like a negative. Maybe that negative 2 over s is a positive. Let me actually just see if that was wrong. No, it was not. Okay. Cool. So now we've done that. So e to the negative s, 2 over t s squared minus is a plus, 2 over s. So that is minor change. That's also incorrect. Let's keep looking at what's going on. All right, let's reset. So let's reset. I want to try this one more time. Let's try one more time. You know, if first you don't succeed, try again. Maybe you'll eventually get it right. Now, I'm just going to walk through this without going into any detail onto why I'm doing what I'm doing. I know that sounds counterintuitive, but let's restart and think about this again from the beginning. The problem at hand is we have an f of t and a t, where it is 0 when t is smaller than 1, and it is 2t minus 2 where 1 is larger than t. That is what we are doing. Okay, where the slope-intercept is at 1. Cool. Now let's just create this problem. So f of t equals the first f of 0. Don't have to worry about it. So we're going to just work on the second one. 2t minus 2 u of t minus 1. So do the Laplace transform of this stuff. That's what we're doing. So the Laplace transform of 2t minus 2 is what? The Laplace transform of 2t minus 2 is 2 over s squared. I'm doing this kind of quick. Minus 2 over s. And I just want to see if there's just something stupid that I missed. Times e to the negative s. Which is exactly what I got last time. Oh, no, it's not. No, it's not. The plus should be a minus. Is that what I got wrong? Let's think about this. So let's go back to that, what the theorem is saying. You know, you want to follow the theorem, obviously. So 2t minus 1 minus 2 ut minus 1. So that's going to be 2t minus 2 minus 2, right? Okay. U of t minus 1. 2t minus 4 u of t minus 1. This equals 2 over s squared, the Laplace transform of this, minus 4 over s times e to the negative s. So this should be something fairly decent. So e to the negative s, 2 to the squared minus 4. So this isn't giving us anything correct either. Okay. This is an interesting problem. Very interesting. Let's see if we're misreading something simple in that theorem. Do I have my book bag with me? All right, we're going to take a little break so I can grab my book bag with some notes in it. Here, let's write a cool little B back soon. All right, you ready? Erase everything. Actually, no. It could be X. Let's do this like. Whoa, that was a weird K. That was a weird K. And then we do... Oh, we screwed the soon up. Soon. Dun. Bam. Deuces. Yo, we're back with a vengeance. All right, folks, we're back with the... I got a new little pin on my jacket. We're back, and all right, we're going to talk more about the thing we were talking about. It's getting cold because it's winter, and we don't, and I can't afford to have heating in the whole house. So, all right. I say that I have like a space heater in here. I'm fine. I don't even think I'm starving. Okay. Let's do the thing. Let's try again. Let's go back. Let's go back and this time we're gonna I'm gonna make reference to a formula sheet that I have, and I'm gonna look at that, see what we get. Behold, the notebook. It's peeking the camera when I look straight out, but whatever. I do manual settings on my webcam. All right. Lovely table of Laplace transforms right here. And let's take a look at the Laplace transforms we have. So, Heaviside function. Okay. It's saying e to the negative. Let's try throwing a negative in front of that answer. In which case I can then explain it. Did Cernal crash? Oh no. It was getting rid of all the other windows and only showing the one. I'm legitimately curious now. No? Let's try that first instance with the negative and see what happens. Okay, that's not correct either. So let's go back to the beginning. A very good place to start. And go from there. So, let's, okay, so, piecewise heaviside functions. I need to remember. I like the word heaviside function better than piecewise. Piecewise is piecewise is boring. It's like heaviside is, man, that's a better name. Okay, so let's go back to the. I threw it all away. I don't know why I did that. I need it within arm's reach. So what I have from my formula sheet is u sub c of t f t minus c equals e to the negative as f of s. That seems very similar to what this thing said. So what I'm curious about is what the difference, what we're doing wrong here. Did I set it up wrong? Is there something else going on? Now, what's that u sub c of t? So let's go back and look at a u notation heaviside function. I forget the name of this thing. Heaviside step function. Is that what it's called? Yeah. Heaviside step function. It's a step function. Yeah, I mean, obviously, it's a step function. That makes sense, because it's a step. Or it's a... boop, boop, boop. I'm trying... I'm trying to remember that I'm, like, mirroring everything. I'm not doing the thing where the webcam is mirrored. This is what you would see if you were looking at me from this perspective. Because I just find the mirror thing weird. Even though it makes a lot of sense in a lot of cases. Oh, it's getting darker outside very slowly. So I may have to change my exposure a little bit. I wish I had a camera, like a proper camera to set up here. And I have a proper camera. I just don't want to set up as a webcam permanently. It would cost me some money to do that, and I don't want to spend money right now that I don't need, because this camera looks pretty great. Looks okay. And I know how to set camera settings manually to the extent that I can generally get the stuff looking good enough. Okay. So this is I'm using like a C920, the Logitech C920. It's the one with the funny mic, dude. Someone just burned out somewhere around here a little bit. You didn't hear it though, because I got a compressor on my mic. Compressors are wild. The math behind that's probably pretty cool. Oh, come on. The problem with the Wikipedia articles is they're very formal. The Wikipedia articles are very... There we go. We're gonna show you guys what we're looking at here too. That's what I was looking at. Heaviside step functions, all this stuff, where it's h of x, and I really would prefer the u. I want to see the u notation. It was like a Fourier expansion of that. This. Ugh. So, it's a different way to notate the same thing. Okay. So t is greater than 3. There's that. Okay. That's what I suspected. I just wanted to make sure that was the case. Okay. So let's come back here and let's go through the motions. So u sub c of t, u to the negative a of c. Okay. Now that c is the thing. So I'm going to use that notation right now. 1 of t times f of t, which is this thing, which is 2 of t minus 1 minus 2 equals e to the negative. Is the a different? It's negative cs, right? Yeah. Negative cs. I was using that a again. Negative s, f of s, which is this. Oh, I'm changing something. What I'm changing is I'm subtracting 2. This is not the same thing. That's what I was doing. That's not the same thing, because I subtracted 1 from the equation. So I have to make it the same. I have to make it the same thing. So I've got to put it in the form of t minus c. I get it now. Okay. We can do this. All right. Okay. So, f of t equals 2t minus 2. F of t minus 1, which is t minus c, is 2t minus 1 minus 2, which is equal to 2t minus 4. We want to get it back into the right setup. Now, how are we going to do this? I almost want to do like a search and replace kind of thing, where we do plus and minus to equate the things. Because if we were to just do the Laplace transform of all this, we'd get the exact same answer we had. But we need to transform it back. I need an example. I need an example of what's going on. We're going to consult the notes. We're going to consult the notes. When in doubt, consult the notes. Consult the notes. Do it. It's important. Okay. I thought I wrote verily in my notes for a second. It was verify. Because I'm learning, I'm still like with the, like me learning the, you can't see it very well. Learning all my, see blue on my camera. Learning cursive. Okay, let's look back. What's the second transformation theorem? That's an important theorem to understand if you want to pass a course known as differential equations, which is what I'm currently attempting to pass, which I will be doing. So, second translation. Heaviside function. Okay. So okay, this is what's interesting. So let me show you what my notes say. My notes say, if you can see that easily, that's the piecewise function. We're going to switch over to a better scene. So this is the piecewise function. We can focus on this, please. Thank you. That's the piecewise function. The piecewise function says that there's too much texture on this jacket. It really wants to focus on the jacket. I get it. Come on, technology. Be technology, please. Thank you. So the piecewise function is it's saying f1 sub 1 of u t minus a minus u t minus b. It's just, this is what I did the first time, right? A is smaller than t is smaller than b, b is smaller. Now, this is a definition of a heaviside function as well, right? And the u of t minus 0, u of t equals 1. Okay, that's the heaviside functions. And so looking at my notes, okay, this is the definition down here. Okay, f of t, u of s is s. Ah, because this is this alternate form, Laplace of f of t times u of t. Aha, f of t plus a, negative as, f of t. Let's try this form, because it has a negative as. F of t plus a. All right, let's do it. Let's do it. I'll read this, and I also want to I need to bump my exposure up just a hair. Just a hair. I think it looks kind of nice as it is, but it's very quickly going to it's gonna start doing me some problems. There we go. It's better. I don't want to do automatic exposure because it's, for lack of a better term, automatic exposure is always doing this, and I have a steady enough light source. I've got like an open window as my light because, hey, that's the best, highest quality light quality you can get. You're gonna get great light rendering from that, especially for you know, your skin tones, especially for a cheaper camera. This is gonna just do the best. Okay. And in reality, it is a little bit bluish, so I mean, you see how much real. Okay, let's go back up here to erase everything. Once again. Let's try that alternate form. All right. So the Laplace of f of t. Actually, let's do this. I'm gonna do this light blue. Laplace of f of t for theorem. Light blue for theorem. U of t minus a equals e to the negative as Laplace of f of t plus a. That should be something we can work with, and because of that, that should be something we can dive into and derive out. Okay, so we now know what f of t is, and we know what f of t minus a is, and we know what a is, and all these cool things. So let's just write this form out. Laplace of f of t, because we already know it's in this form, equals e to the negative s, because negative 1, times the Laplace transform of f of t plus a, which is 2t plus 1 minus 2. Oh, I'm still in light. Whatever. Consistency is for nerds. All right, we're going to do this. E to the negative s. 2t plus 2 minus 2. That goes away. It's just 2t, which is 2 over s squared. That should give us something good. And simple. It's simple. That's a good sign. Okay. We may have the answer. No one freak out. That makes more sense. That makes way more sense. All right. 2 over 2e to the s over s squared. Okay, that's also incorrect. Oh, e to the negative s. Bam! We did the thing. We got the thing done. Okay. That's one problem done. Okay, we figured out the second translation theorem in a way that's cohesive that we can do the problem. Okay. Wow. That's an advanced math class, folks. That is an advanced math class. I know it didn't functionally it took about 30 minutes of study to do that one problem, but now that I know it, everything else should go much more smoothly because now we figured out the problem. We don't have to solve that twice. We don't have to solve that twice. All right. So we're going to do this. And then I'm going to select this and delete it. All right. I'm also going to make another one that's blank so that I don't have to erase everything a second time on the new page. Okay. So we're going to do another piecewise. I'm going to start doing more funky colors because I'm bored with unfunky colors. F of t equals negative 14, where 0 is smaller than or equal to t, and smaller than 6. And is 14, where t is greater than or equal to 6. Okay, so the first thing we're going to do is we're going to define this thing in terms of its functions. Functions. All right, so f of t equals, what's f1? Negative 14. Times 1 minus, or u of t minus 0. That is 1. But we're being explicit. Minus u of t minus 6. All right. We've done the first part of this guy. Now we're going to do 14 plus 14. Where u of t minus 6 in the positive. Ba boom, ba bing. Did it. Is done. So. Oh, shoot. There we go. So now we're going to set this up in such a way that, makes some sense. So it's minus 14 plus 14. Oh, no. Plus u of t minus 6 times 14. Whoa. Minus 14 plus 14. Why? The negative and the negative cancel. This negative, doot, 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 doot. And the negative, doot, 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 doot. It's 14 and 14. It's 28. So pretty straightforward. So negative 14 plus u of t minus 6 times 28. So 28u. 28. Let's just do that. 400 plus 28u. Plus 28u. Plus 28. All right. Now we've distributed everything and made it basically understandable. Oh, you know what I wish I could have like a little put a little border around me. I feel like that makes some sense, but I scroll. The problem is the minute I scroll, whoop, it no longer matches. That's annoying. I'll have to figure that out. I'll have to improve the streaming setup is what I'll have to do. You know, we're going to improve the stream. I want to add music, maybe background music, but I want it to be good. I don't want it to be like lo-fi everything. And I used to, and there's certain lo-fi, it's good, but it's like most of it is like the same. So I don't want it to be. I want something cool and unique and interesting. And my brother writes music. I write music. Most of my music is cinematic spacey music, which doesn't seem like it fits for kind of chill like this. And I'm not 100% sure what the difference is going to be. I'm dropping more frames. I'm dropping like 2% of my frames. I'm seeing my stuff drop out. But I'm hardwired to a gigabit connection. Oh, I mean, our maximum upload speed on this connection is 35 megabits per second, which is fine because I'm at 6 megabits per second. I'm uploading an H.265 to save on the bandwidth. Whatever, I digress. It's none of y'all's concern. So, although it's an interesting topic. All right. Now we can do the addition stuff. So this is going to be equal to the Laplace transform. Oh, whoa. Hold on. Let's change colors to hot magenta. Look at that. Oh, nope, not yet. Hot magenta. Yo. All right. The Laplace transform of f of t equals what are we looking at? What is it equal to? What is it equal? I don't know. We've lost the plot. I'm going crazy. The Laplace transform of -14 plus the Laplace transform of 28 times u times t minus 6. Okay, so now we're going to now the cool thing is we can add this stuff pretty easily, or we take the multiplications out, we're going to do all this stuff. All right, let's do it first. All right, Laplace -14, that is -14 over s. Very straightforward, very simple. The Laplace transform of a constant is just the constant over s. Done. If it is the constant times t, it's the constant over s squared. If it's t to the n, it is in factorial over s to the n. It's s to the n plus 1. Yeah. So, but we'll get into that if we get to a problem there. So, oh, just see me. I'm streaming at 30 FPS, which is fine. I don't need 60. I just need 30. Okay. I would do 24, but my monitor is 60 hertz, and you want to divide that evenly to get something smooth. You'll get weird tearing effects. Most monitors do not support a native refresh rate of like 24 frames per second or a multiple of that. Okay. So now that we got that, and I've distracted myself a few times by talking about video things, plus, now this 28, we can pull that 28 out. Laplace of u times t minus 6. Oh, that's easy, because it has a value. It's in the table. My nose is for the ground. It's in the table. Okay, so in the table, and there's a way you can find this stuff. So for any u, and we're going to do this in orange, for u sub c of t, which is, by the way, equal to u t minus c, equals e to the negative cs over s. That's pretty straightforward. So here's what we're going to do. Equals -14. We're still in orange, even though I think orange actually looks quite nice. Most people, I think, don't like orange over white. I mean, the magenta over white's clearly an ugly color, but we're living with it. Oh, look, I'm covering part of this up. That's bad. There we go. There. So now, So here's what we're going to do. All right, negative 14 over s. Negative 14 over s plus 28 times Laplace transform. 28 times e to the negative positive 6. Wait, no, I'm wrong. Minus c. Negative 6s over s. We went. We did the thing. We did the thing. But they're both with an s in the denominator. So it's 28 e to the negative 6s minus 14 over s. It's one fraction now. So that's great. Now let's move on and start talking about, now that we've done this, let's see if it's correct. Come on, computer. Don't tell me I'm wrong now. 28. It's correct. It's correct. The computer says so. The computer says it's correct, so it's correct. And I, for one, welcome our robot overlords. For legal reasons, that's a joke. Don't go for me. All right. What is another horrible color I could... White! You can't see anything. Okay. So, I like orange. We're just going to go with orange. Because, yeah, no gods, no masters. We're just doing orange. Even though I was doing orange for, like, theorems. So, problem 5. The next problem. F of t equals whoop t, where 0 is smaller than or equal to t is smaller than 7. I don't know what just happened to my screen again. I'm getting weird flashes. I'm still on Windows 10. I'm trying to switch over to Linux, but I write music, and that has been a very difficult transition to make. And we can talk about that at a later date. Audience of 0. So, I'm schizophrenic now. I'm officially... And we call that e-schizophrenia or something, or internet schizophrenia. 7, where t is larger than or equal to 7. Okay. So, but yeah, long and short of it, yeah, I think Windows may be screwing up because it's no longer getting updates, and I need to be very careful of being connected to the internet. Because 0-day exploits are just... Microsoft is not gonna... They're not gonna support that. And I need to move myself to the Penguin. I mean, I'm on the Penguin on my laptop, and I've loved it. And most of my software is free and open source software where I can use it. In fact, yeah, this entire live stream is run on FOSS stuff. Like the OBS is running the thing, and the software I'm using is free open source software. It's called It's called Zernal ++, or XOURNAL ++. So journal, but with an X in front of it. And it runs natively on Linux. In fact, this is a port from Linux. You can see these are GTK things. So you really couldn't tell what OS I'm on if I wasn't showing some of the telltale signs. Because I have like a KDE cursor because I'm crazy. Anyways, so we're gonna write this out like we did. F of t equals, what's F1? T times u of t minus 0. Minus u of t minus 7, because we're turning it off when it's at t equals 7, plus 7 u of t minus 7. And I add some extra parentheses there, so now we're going to simplify it. So it is now just t. The u of t minus 0 is just 1. And plus 7... Oh, no, not 7, sorry. I always do this. U of t minus 7. 7 minus t. Bada boom, bada bing. Now we're going to do the Laplace transform. The Laplace transform, now we're going to do the first part's easy, like we said. So the Laplace transform of t plus the Laplace transform of u of 7 times the Laplace transform of u of t minus 7. I'm actually going to split this up into one more set of Laplace transforms, plus the Laplace transform of t u, or sorry, minus the Laplace transform. It's minus the Laplace transform. Minus the Laplace transform of u of t minus 7. And it did the flash again on my streaming software. You guys can't see that, but that was weird. I mean, if it works fine, it works fine. I've been streaming for an hour and 18 minutes, about to be an hour and 19 minutes, and I'm doing okay. I'm hanging out. But I don't like that 2% of frame drop. It's annoying. I digress then. So, it's whatever. So the next thing, sorry, I'm looking outside and it's like a beautiful day out, and I'm like, I want to go outside, but I gotta do math. I gotta do math. And I do better during the day with math than at night. Maybe I'll do a second stream tonight or something like that. I don't know. We'll see. Maybe not. Goal is to get as much of this done as possible. So, now that we've done that, we can say the Lagrange of, Laplace transform of t is 1 over s squared. Plus 7 times Laplace transform of u minus 7 is e to the negative 7s minus, now we've got that thing. We've got the thing. It's the thing. There's two options we have. U sub c to the t times t f to the t minus c, f of t minus c. Okay. So we're going to do this. Is the Laplace transform, or sorry, it is minus e to the negative, to the negative 7s times the Laplace transform of t. That's what it is. Wait, or is that what it is? Because here's the annoying thing. This is the confusing part. Because this is what I want to point out. Because I'm actively learning this. L of t minus 7. So L of t. And L of t minus 3. Or sorry, L of t minus 7. Is the two options we have. And it's because the theorem says u sub c of t times f of t minus c equals e to the negative c s f of s. Okay. Is f of s, I believe, is times the Laplace of the original. I gotta go look back at my notes. I think it's times the Laplace of the original. It's just very confusing sometimes to watch and read this stuff in a way that's cohesive, because it's something that there are a million different ways to write this, and a lot of them make you feel like you're thinking backwards. So okay. So my stuff is saying minus as, or cs in this case, f, the Laplace of f of t plus c. So we're just going to do that. In which case, we're going to do, back to orange, we're going to say equals 1 over s squared plus 7e to the negative 7s minus e to the negative 7s Laplace of t plus 7. Here's what we're going to do. Actually, we're just going to do plus 7. And here we're going to split it with the parentheses here. And we're going to just do it as two Laplace transforms. And the reason I'm splitting these plus the Laplace of 7. The reason that I'm being really explicit about splitting all this stuff up is because it's important when you're doing... What is with my frame dropping? We're going to have to figure out why that is. It may be a good idea. This is an interesting idea. It may be a good idea to try streaming through a VPN. That could help. Because sometimes when you're routing a signal, it gets stuck at some weird junction in the internet. But if you're basically tunneled directly into a massive data center, guess where everybody else is? At the giant data center. Or close to it, or it's more efficient. It could be just more efficient because I have a high-speed VPN I can use. So might not be a bad idea to do that. Just as an idea. But I digress. Because I think the YouTube ingestion servers that I would be closest to are the ones in Texas. All right, anyways. We'll have to figure that out. We'll figure that out later. It'll be a fun little project. So... to finish this problem off, the answer is 1 over s squared plus 7 e to the negative 7s minus e to the negative 7s. Lagrange of t, 1 over s squared plus 7 over s. And we could distribute that e to the negative 7s. I mean, we could say 1 over s squared plus e to the negative 7s, 7 minus 1 over s squared minus 7 over s, makes it a little bit shorter. I just kind of like a clean equation, but sometimes you want to not simplify if you're putting it into a computer. You just want to be explicit. Let's see what happens. 1 over s squared plus e to the negative 7s, 7 minus 1 over s squared minus 7 over s. See if we got some stuff wrong. Okay, it's not correct. What did I do? Did I accidentally type it in wrong? Was there something incorrect about the way that I distributed something? I'm just going to do the other form. Okay, so I did do that transformation correctly. 1 over s squared plus 7 e to the negative 7s minus e to the negative 7s. 1 over s squared plus 7s. 7 over s. Let's see what we got wrong. See what we got wrong. Let's kind of work on. See what we got wrong. This is how you learn this stuff. Through trial and error. A lot of looking at stuff. A lot of looking at stuff. So I want to try just doing L of t, which is just e to negative e to the negative 7s over s squared. I want to try it. I want to see if that's more correct than what we did have. That's also not correct. So I think... Now I'm curious if it's that it was minus 7 and I'm misreading my notes. So it's 1 over s squared plus 7 over s. Sometimes fiddling around with these answers can help. Okay, also not correct. So I think... Nope. It was minus. Okay. So... That's kind of weird. Ain't that a little weird? Whoa. I just saw more stuff drop. That could be our problem. Yeah. Okay. We're going to take another quick break since we're coming up on a little bit more, almost an hour and a half. I've been doing this for almost an hour straight, so we're going to take a little break. Remember, do 50 minutes, 10 minutes off. So we're going to take a little break, and we'll be back soon.